AP Stat students, happy Monday. Hope you're enjoying your day off from Zoom. What I would like you to do is watch this video and come to class ready to discuss and ask any questions that you have over the power law. Tomorrow also we will be discussing the difference between power law problems and exponential problems that we did on Friday. Okay, so a little bit of algebra that you need to know before we apparently I can't erase those, sorry, get going on power law problems is a couple rules that you learned for logs. The first one was about exponents. If you have an exponent within the log, you can bring it out in front. What I started doing then I changed it, is usually in algebra you started here and went this way with it. We will be going this way with it, so just kind of pay attention to that. The second one is if you have two logs with the same bases, log of x plus the log of y, you can combine them into one, but you have to multiply inside. You also need to remember all the rules that you learned on Friday about logs. We will still use those same log rules as well, but these are two extra ones you need to know for today. So the power law is y equals ax to the p power. Anything with a power, it falls into this category with a y-intercept of 0, 0. So it has to start at 0, 0 for this to work. If it doesn't, then we have to go back to what we did on Thursday, which is kind of no fun. But power law problems follow this form. So when you learned about quadratics, so x squared, x to the third, x to the fourth, x to the fifth, all of those fall into here. Radicals also fall into here because those are like x to the 1/2, 1/3, and so on like that, as well as negatives, exponents, negative first, negative second. So there's a ton of things that could fall into this section of power laws. So let me show you why we're going to do what we're going to do. If this slide is a little confusing, this is really just to explain why we're taking logs and how we're taking logs. So the first thing I'm going to do to that power law equation is take the log of both sides. So I have the log of y equals the log of ax to the p power. On the right-hand side, I'm going to split that up using logs. So I can split those up. Those are getting multiplied, so I can split them up and add. And then the third thing I'm going to do is bring that p down in front. From this point, what you should realize is that these two numbers are numbers. I shouldn't say these two numbers. The log of a doesn't look like a number, but once a is a number, then the log of a is also a number. And p, the power, will also be a number. So here's the idea. If we take the log of x and the log of y, we have a linear equation. This becomes our new y equals, this will be our y-intercept, log of a, plus b would be our slope of our line, log of x. So when we see power law problems, we are going to take the log of x and the log of y. That is what we will do when we think it is a power law problem. Like I said at the beginning, you don't need to worry about today is how am I going to decide if I should take the log of just the x's and the log of x's and y's. We'll talk about that tomorrow. Okay, so a little bit of notes. I wouldn't write all this down, but if you'd like to, there's a lot of things that fall into this power law model. Lengths and weights, a lot of things go up with powers. So anything that's area is squares, anything that's volume is cubed, like the fish problem that we did a couple days ago. According to your book, pulse rate, length of life, and a number of eggs a bird lays also falls into this power law. So there's a lot of things that this power law problem will do. Okay, if you'd like to follow along, what I'd do right now if I were you is pause the video and type these into your calculator. I've already done that, and I hope I didn't make a typo. I've looked over it 3 times. I think there's a typo, so if you're not getting exactly the same numbers as I am, it's probably a typo on my end, but I've looked over and I can't find one. So anyway, type these in your calculator and pull it up. Ignore that for a minute. Okay, so I have typed them in my calculator. And let me get rid of these. No. Oh, goodness gracious. I don't think I can save this. Let's see if I do that. Did it save my list? Oh, it did. Okay. Phew. I didn't want to clear that list. I wanted to clear this list. Clear this list. And L4. Okay, so I'm going to tell you that this one is a power law problem. and I will show you the scatter plot so you can see that it definitely has a curve to it. Like I said on the first day, it's really hard to tell if this curve is a quadratic or a cubic. The beauty of doing this with the logs is you don't have to decide what the power is. It'll decide for you, like what the exponent should be. Okay, so I'm telling you that it's a power law problem. So that means in our L3 and L4, we are going to take the log of both the x's and the y's. So in L3, I'm going to hit enter. I'm going to make sure this is blinking down here at the bottom. And I'm going to hit log L1. And then in L4 over here, same thing this time, but I'm transforming both the x's and the y's. So I'm going to log L2. Now I've transformed both of those. I'm going to do a line of best fit on both number 8 of L3 because I transformed my x's, and L4 this time because I also transformed my y's. And I'm going to hit calculate. I would write out quite a few of these decimals because it'll end up playing a role in what it is. If you got, I forgot what the other numbers that I had saved on my PowerPoint were, but it was really close to this, but not exactly. So like I said, if you get slightly different numbers, don't panic. I have a feeling I had a typo, but I looked and looked and couldn't find one. So hopefully you got the same numbers I did and my PowerPoint was wrong. Okay. Usually if we were in class, somebody could like help me find it, but not today. So when we write this, remember we took the log of x and the log of y. So let me get my pen working here, just like class. This would be the log of the weight equals negative 4.4188 plus 3.286. And then this was the log of the length. Once you write it once, you don't need to worry about writing that every single time, the weight and the length, but I'd at least like you to write it for the first one. Okay, we are going to use our log rules to simplify this so that we can get this into a power problem. So we are going to take both sides and those are going to become the exponent of 10. So I'm going to be doing the 10 log of weight equals negative, 10, sorry, to the negative 4.4188 plus 3.286 log of length. Raising something to the 10, that's not the right way to say it, but you know what I mean. Those will cancel out, so you get weight equals. Over here, I have two exponents being added together, just like we did on Friday. So I have 10 to the negative 4.4188 power. And then I need to multiply that by 10 times 3.286 log of length. I'm going to switch these two around and hope that I have enough room for this. 10 to the negative 4.4 power is a really small number. I hate it when it does that. And then I'm going to have 10 to the log L power, and then I'm going to multiply that by 3.286. These end up canceling out. So what you end up with is W, and if you take 10 to the negative 4.418 power, you get a really small number, 0.000038. Now, those cancel out. The L goes down to becoming the base. That's a little strange. It was in the exponent, and now it becomes the base to the 3.286 power. So like I said, length and weight are related by the third power. This is being a lot more exact. It's saying by the 3.286 power. Okay, let me do another example of this just so you get the idea of it. The next example I'm going to do is the one of your from your homework from Thursday. But this one I'm going to take the natural log. You should be able to work with natural logs or logs while doing this. So once again, I would pause your computer right now, pause the video, and type those in your calculator if you'd like to follow along. Let me get my calculator out here. Okay, and I have my data in this calculator. Hopefully I didn't make any wrong moves here. Does not look like I have an outlier or any typo because this looks like a nice, pretty curve going on here, a very strong curve. So the book says that this is also a power law problem. So I'm going to go to calculate linear regression. I'm going to take the, whoops, sorry, not that yet. I need to go back to my list. So I'm going to hit stat, go to edit. I'm going to go over to L3. Make sure it's highlighted, make sure it's blinking. This time I'm going to take the natural log of L1. It does not matter which one you choose if you're doing it by yourself. However, you have to be able to start this process at any point, so you need to be able to work with natural logs or logs. And now I'm going to natural log the y's, so natural log L2. Now I'm going to do linear regression on L3 and L4, so I'm going to go to stat, go over to calculate, number 8, L3, and L4 this time because I transformed both of them. And I'm going to get my numbers, 2.5585 plus negative 0.8134. Yes, I did say plus a negative, and I'm actually going to keep it that way. Okay, let's go back to this problem. We made a scatter plot. It looks like it's a strong negative curve. We took the natural log of both sides, and here's our equation. We had the log of pressure, don't forget that both of them were logged, equals 2.5585. I am going to write it as plus a negative, just like your other teachers would have hated. And then to save room, I'm going to write log of volume because I don't have enough room to do that. Except I need to erase these because it wasn't logs. It was natural logs. I took the natural log. So let's fix that. Okay, so when we take the natural log, the way you get rid of it is with an e. E to the natural log p power equals e to the 2.5585 plus negative 0.8134 log of v, or volume. Those cancel out. You're left with p equals e to the 2.5585. I would write out as many decimals as, I don't want to say as possible. 4 to 5 is probably better, other than 2 to 3. You can get major differences in what's going on here. You're multiplying. Don't forget you are multiplying e to the log v. I'm going to change these around and put the negative 0.38134. The reason I didn't want to write subtraction is because when you subtract two exponents, you usually divide, which is okay, but I would rather have a negative exponent for this section. The e in, oh my gosh, I wrote log again. What's wrong with me? The e of the natural log. This was natural log. I'm not just changing it. The e of natural, and I wrote it up here too. I'm not redoing my whole video just to fix that. Here, we'll just fix it right here. Natural log. E and natural log cancel out. If that was a regular log, that would not work. So you need to find e to the 2.55 power. E is right above the natural log button. 2.5585 power is 12.916. Like I said, if you're getting slightly different numbers, it might just be because I made a typo, or maybe you made a typo. So remember the e and the natural log cancel out. This goes down to becoming the base, and then the negative 0.8134 is your power. So what I would like you to do is look over your homework, check it, see if you can do a couple of them, and then go from there. On Tuesday, tomorrow, we will talk about any issues you had and also try to discuss the differences between them. If you have any questions, feel free to email me now or just talk to me tomorrow. Have a good rest of your Monday.